Well, good evening and welcome to Dome at Home, the Manitoba Museum's award-winning planetarium astronomy show. I'm your host, Scott Young, planetarium astronomer at the Manitoba Museum, and we have all sorts of great stuff going on in the show for you today. We're looking forward to bringing back some of our previous features. We're going to be having a binocular challenge with Ulrike Schreckenbach, one of our longtime contributors here. We're going to be looking at the planetary parade that is going on right now above the clouds that are currently covering most of Winnipeg. We are broadcasting from here in Winnipeg, Treaty 1 territory in Manitoba, Canada. And please say hi in the chat. Let us know who's watching and where you're watching from. It's always nice to see all the people pop up into the chat. We're still down to one monitor here, so I may be a little bit slower getting to the chat than I am sometimes, but hopefully we'll be able to make that all work out. Let's go. Here we go. Oh, I see a few people. Oh, wow, lots of people checking in. This is great. Okay, awesome. Okay, so we are going to be doing a number of things today. We're going to start off with some of your images. It's always nice to see what you're up to over the course of the month between shows, and we got some great images to show off today. We're going to look at what's up in the sky, particularly the planetary parade, as they call it. And then we're going to move on to our feature of the evening is actually going to be the lunar eclipse. We're going to save that for the end, but we'll move into binocular challenge, and then we'll move into cool space stuff and all those kinds of things. So, jam-packed show. For those of you that have been trying to watch the sky, we've had two types of skies. We've had minus 45 and frigid, and we've had plus 4 and so humid that everything clouds over. There's been a little gaps here and there where you might have been able to see the sky a little bit, but hasn't been great observing, I would have to say. I mean, if you can handle the minus 40, at least there's no mosquitoes, but it's been hard for me to get out, I know. And so yeah, I'm just looking forward to being able to maybe do a little bit more observing as the weather warms up a little bit and hopefully also clears up. Let us start off with some of your images. Fallon, great shot of the snow moon. She took this shot. And many of you will have met Fallon out at the last eclipse that we went viewing as a group, I think out at Birds Hill Park. Fallon was the person who also spotted the Starlink satellites during that event, and everybody got to see that. Anyway, this is a great shot of the moon through her telescope with, I believe this is a cell phone, and really, really nice. I think in the email, this is 99.9% full. That's about as full as you can ever have the moon, because if it was 100% full, it would have to be directly opposite us in the sky. And in fact, that will happen next full moon during the lunar eclipse. That's the only time you can have the moon more full than it is in this shot. I really love how all the white parts of the craters, the rays around Tycho down at the bottom here stand out. That's an awesome shot. So great job, Fallon. Let me see here. We also have a couple of shots. Andy and Ruby were out and managed to get, this is the kind of night that we sometimes had to make do with. This was just after the last show. We talked about the conjunction of the moon and Venus and Saturn. So you got the moon down at the bottom and Venus up at the top. And Saturn is right in about there. It's kind of hard to see, but much fainter there. And then 2 nights later, it was clear. So Andy was out again with his camera, and we got this shot. And it really dramatically shows the difference that just a couple of days can make. First of all, you've got Venus. Venus is essentially in the same spot it was 2 days ago, but the moon has moved from way down here to way up here in 2 days, and Saturn has dropped lower into the sunset glow. In fact, you might not even be able to see it here. We'll just pull it out there. There's Saturn. I had to bump up the contrast to be able to really make it obvious on the stream. Great shots. I love seeing your images, Andy. You always have these great wide field shots with some, context, the trees and stuff like that. We love seeing your images. You can always send them to space@manitobamuseum.ca, or you can catch us on any of the social medias or things like that. It's not a competition. We're not trying to show only the best necessarily. Anything that you get out there and you take a picture of that you enjoyed is worthwhile. And I think it encourages people to go out and try their own hand at capturing these images. So great job, Fallon, and Andy and Ruby. Thanks a lot for contributing. Okay, let's see. I think what we're going to do is we're going to go into the planetary parade. I've done a bunch of media yesterday and today, and I'm doing CTV morning show tomorrow to talk about this planetary parade, which has become such a big deal, apparently. It's interesting because it's not a real thing. I mean, it is. The planets are lined up in the sky, but they're always lined up in the sky. That's what happens when you're in a solar system that is flat and all the planets are going around roughly in the same plane. If you're one of these planets, all the other planets are going to be kind of in a line from your point of view. I guess the difference is right now that line is all concentrated in the evening sky, and so as well you can see them all. Not quite. Usually when these things get started, it's because someone has done a Google search or looked in an almanac and found something like, oh, the planets will all be visible on X date at their closest, without realizing that, you know, it takes weeks for them to get into that position and weeks for them to move out of that position. So it's a really long event. Net result, don't worry about missing the planetary parade tomorrow if it's cloudy, because you could see it tonight, you could see it any night the last month, you can see it in the next month. It's one of those things that we can see very, very easily because these planets are all so bright, or many of them are so bright. So let's pop over to our favorite planetarium program, Stellarium. If you have been out, you might have noticed the return of the Big Dipper. The Big Dipper is finally starting to come up in the northeast after dark, standing up on its tail there, and that's always a sign of spring. You know that spring is coming when the Big Dipper gets above, well, I know it's coming when it gets above the roof line of my house, but as soon as you can start seeing that Big Dipper, you know that spring's coming along. If we go around all the way to the west, you've probably seen Venus in the last little while. If you've seen the sky at all in the evening, you've seen Venus. It's the brightest thing in the sky other than the sun and the moon. And it's down pretty low once the sky gets dark. But what we'll do here is we'll just make the sky a little bit less dark. We'll go back to sort of a time just after sunset, because that's really when the best view of all of the planets will be. Oh, and I see that I'm using the landscape here that has trees right in the way, just like my house. Oh yeah, there's my house. That has trees and buildings in all directions. Let's just go to the theoretical zero horizon. This is like if you were on the ocean, this is be where your horizon is. So this is the sky about 6:40 p.m. tonight. Again, through the clouds because we can't really see this kind of view. Venus, super bright, super easy to spot. Down below it, 2/3 of the way to the horizon, is Mercury. And Mercury is rising higher and higher for the next week or so. And I think that's why they picked the 28th as being the best date, because Mercury has risen high enough, and it's the hardest planet to spot. It's always close to the sun, very close to the sun. And so we really only have a couple of weeks in the evening and a couple of weeks in the morning each year where we can actually get a decent view of it. And this is those 2 weeks, the first 2 weeks of March. So there's Mercury. And if we zoom way in, theoretically, down halfway between Mercury and the horizon, this is literally a degree or so above the horizon, there's Saturn. So while technically Saturn is visible in the evening sky, you're not really going to see it. The sky's too bright. Unless you have perfect conditions, even a pair of binoculars might not reveal it. But according to the almanac, it's on this side of the sun, so it counts as part of the parade. Personally, I'll be pleased if I can just spot Mercury, because Mercury is, I mean, while it's bright, it is in that bright twilight haze, and if there's any clouds or things like that, it really sort of piles up near the horizon and makes it hard to see things. So if I spot Mercury, I'll be good. Sure, I'll look to see if I can see Saturn with my binoculars, but I don't expect it. So that's one of the planets sort of right off the off the planetary parade list right there. Another one you can cross right off is Neptune. Neptune is right about here. Oh no, wait, sorry. Neptune is right about here, up from Venus. But Neptune, you need really good binoculars or a small telescope to see it at the best of times. And in the bright sky like this is not the best of times. You're not going to see Neptune either. So even though technically it is in the sky, it's not really part of the parade either. If we widen out our view here, though, we do start to see other planets. So we've got Mercury down here, we've got Venus. Over here is Jupiter. We've been watching Jupiter for months now, and it's there in the sky, still doing its thing. And if we go even farther, if we sort of turn our view here, we've got Mars over here. And so look, they're all in a line. Mercury's sort of down a little bit from that line, but that's partly the distortion of the curve here. But look, we're looking from the west all the way to the southeast. I mean, we're looking across the whole sky. So I think the problem is people expect, oh, there'll be all these planets right beside each other in a line because those are the pictures that these things will come out with. And in fact, it's not like that at all. Far be it, though, for me to dissuade anybody from going out and looking at the stars. I mean, any night you go out and look at the stars is a good one. And so I guess my point is that if you think you miss it on the 28th, don't worry about it, because anytime in the next week or so, actually, it'll even get better because Saturn sinks lower and lower, but we already won't be able to see it. So that's a write-off. But Mercury gets higher, so we'll actually have a better chance of seeing Mercury into that first week of March. So the way I count it, let's see, that's Mercury is 1, Venus is 2, Jupiter is 3, Mars is 4, and then Earth is 5. That's 5 planets all at once. That's pretty good. Uranus is also up there. It's around about here, and you're also not going to see it. It requires binoculars. You might see it later after the sky has gotten dark with binoculars, but by that point, Mercury and probably Venus have already set, so it's not really part of the parade either. But really, Mercury, Venus, Mars, and Jupiter all in a line, that's pretty cool. Okay, now the other thing that gets added to this is if we wait a day or so, another object joins us. And I'm going to have to zoom in here because Stellarium shows it as a big round thing because it's bright, but it's actually the thin crescent moon. And when I say thin, I mean like razor thin. This moon is 24 hours old, 24 hours past new, and that is really, really hard to see. Seeing the moon tomorrow night on the night of the 28th will be a very big challenge for anyone and will probably require binoculars as well. The following night, though, oh, now I have to zoom out. The moon is quite a bit higher. So on March 1st, I would say this is, if you've got a choice, this is the night to go out, because March 1st, Mercury's gotten a bit higher, Saturn's already gone, but here we have a beautiful crescent moon with a nice thin, look at how slender that crescent is going to be. That's going to be a beautiful sight in binoculars or even to the unaided eye. 48-hour-old moon, and we'll almost certainly see a lot of earth shine lighting up the dark side of the moon. That's sunlight reflected off the earth and back out to the moon, lighting up the dark side a little bit so we can see it. That's my favorite phase of the moon, I think, is when it's a thin crescent like that. So March the 1st, that's the time to go out. If you go out on March the 2nd, well, the moon will just be up a little bit higher and it'll be a little bit wider of a crescent. Here, there we go. Now you can sort of see it's a crescent. Venus and Mercury will just be getting better and better. And pretty much for the whole first week of March, Mercury gets a little higher, Venus gets a little lower, and the two of them just sort of pull closer and closer together. Unfortunately, by about the 7th, Mercury starts to fade away as it goes around the part of its orbit where it's showing us a crescent phase, just like the moon did, and like Venus is right now. And that means it's not reflecting as much light. It sort of gets fainter, and it'll be hard to see. So by about maybe the 8th or the 9th, Venus and Mercury will pass each other, but then Mercury is just going to be too faint to see until you go out a little bit later in the evening. Maybe if you wait a little bit longer and wait for them to get closer to the horizon, they'll be easier to spot. And so this is more like a, 8 o'clock. And then, of course, on the 9th, that's when daylight savings time starts. We spring ahead, so we punch the clocks an hour forward. I'm going to not rant about daylight savings time this year. I'm not going to do it. But it does adjust the time that we go out to see things. And so if you go out at, 8:30, Venus and Mercury will be quite low to the horizon, but you'll see them in a darker sky. So the western sky is the place to watch for all the planetary action for the next week or so. We'll talk a little bit more about other things that are up later on in the show, but I'm going to give our guest a little bit of a warning so they can get over to the other computer and get all set up. We're really excited to be able to bring back one of our regular contributors. And every time we had done it for the last 3 times, we had some major audio issues. And so we took a day where we actually did a full test stream where we were streaming to Facebook, and everything worked. And the settings are exactly the same. And I'm sure that everything is going to work perfectly this time. And so we're going to go into our binocular challenge. And Ulrike Schreckenbach has been observing the sky with binoculars as long as I've known her. And she's going to tell us a little bit about a target that you can go out and see this month with any kind of binoculars. And so let me make some magic happen here. And hello, Ulrike, can you hear me?
I can hear you very well, Scott. Can you
Great.
hear me?
I can hear you. Can you people out in internet land hear Ulrike? That was the problem last time. I could hear her, but no one else could. Let me just get to the chat here so I can make sure that, in fact, all this
Yeah.
is working. We have to wait a few minutes or a few seconds because there's a delay in the stream. And so hopefully someone out there will tell us that they can hear you. Anyone? Yes, yes, all right.
It's
Excellent.
working.
Yes, it's working. Okay, so
And a friend of ours says technology is great if it works.
yes, that is exactly right. And we find that in astronomy a lot, as well as in streaming. So I'm going to switch you over to your stellarium view here, and you can tell us a little bit about what you would like to talk about.
Well, the object I wanted to talk about is NGC 2238, and I came across it, of course, when I was looking for something else. And the area of the sky we are looking at is our winter friend Orion.
Okay.
Maybe you
Yeah, let me
would
just get to the PowerPoint. I have too many windows. There we go.
is Orion. And I mean, we all know it at least for the one, two, three, four, like the 7 really bright stars. But we are going to use some of the fainter stars of Orion too. And it's also a nice way to meet another to meet another constellation, a fainter one. It's called Monoceros or the Unicorn. And that's essentially in the big triangle of Betelgeuse and Procyon and Sirius.
Right. And we've talked about, I think, the winter triangle before. And so all the stuff in the middle there is part of Monoceros.
And I mean, a unicorn is essentially a horse with an extra horn, right? And I always thought this almost looks more like a horse than the winged horse does. So,
Oh, then Pegasus. Yeah, for sure.
yeah, Pegasus,
Yeah, yeah.
that's right. And of Monoceros, we are going to use like the 2 upper right stars. I always thought of them as the nostrils of the horse and the forehead of the horse.
Okay. So these two here,
And
yeah. And actually
yeah,
I've got a little zoom in view here just to make it a little easier for the stream. So these two here.
so the lower one would be the sort of the nostrils, and the upper one would be the forehead.
Okay.
And I mean, people with telescopes will or might see the Rosetta Nebula when they look at that constellation, but for binocular observers, there is a nicely arranged group of stars. I sort of fell in love with it when I saw it and found it. So, and the nice thing about this constellation is that we can cross-reference it. So there are several ways to arrive at that point. And the first two start us from Orion, and the last one really just uses Monoceros. Alrighty, let's hop right into it. Hop right into the star hopping.
Okay.
And we would start with Orion. Uh, the ones that we easily see are basically the two shoulders. Then in the middle, there's a little bit higher one. And when a human figure is attached to it, that's usually shown as the face.
Mm-hmm.
And so we would start at the face of Orion and then move on to his right shoulder, like where the upper arm is.
Okay.
And then we keep going in that direction
Okay.
about just let me take a look at my notes here.
Yeah.
Yeah, about one and a fifth or one and a half, so just a little bit further than the first distance.
Mm-hmm.
And then we arrive at that somewhat fainter star, but it's still brighter than the surrounding stars, like the forehead of Monoceros.
Mm-hmm.
And here we turn right,
Okay.
about 45 degrees,
Oh
and
yeah.
then keep going straight about a quarter of the distance that we had between the face and the shoulder of Orion. And then we are arriving right at NGC 2238.
Nice. Yeah. I've never looked for this visually before. I've looked at, with my camera and imaging rig, but because I always avoid it, I've never seen Monoceros. I've never been able to find any of the stars. They're just so faint for me. But binoculars are the perfect way to do that.
Right. Then let's go on to the second way.
Okay.
We are still starting at Orion, but this time we are starting at his upper hand, like he has raised his arm, and then yeah, from the right shoulder, then up this arm, and then a little bit further in, you can see his hand. Yeah.
Yeah. These ones up here.
Yeah, so that's his elbow.
Okay.
If you go a little bit further up, it's like two stars,
Yep.
and they are sort of his hand.
Okay.
I that's the way at least I looked at it and tried to describe it. So you go from his hand, you go down to his elbow. That's like where the big bend is.
Mm-hmm.
And then you keep going that way. 1 second. So yeah, so you go from his hand to his elbow, then keep going in the same direction, but about 1.5 times the distance, and then take a wee little turn to the right, and again you're landing right at Monoceros.
Yeah. That's a good cross reference because these stars are so faint. It's definitely hard to know you're on
Yeah.
the right one. But going from the head of Orion that way and then going down from the arm, that triangulates really nicely. You've made that way easier for me. Thank you.
Yeah, like for the Monoceros stars and also like the hand and elbow of Orion, you really need a dark sky. But I try to look at it the other way around too. That's a way to get acquainted with the fainter stars. And like when you look at the sky a little bit longer, you definitely see them better.
Right. Right.
And now we are going really with the faint stars. We go back to Monoceros.
Okay.
And we go to the nostrils of the horse.
Oh, okay.
That one, yeah.
So,
Then you go up to the forehead of the horse. Then you turn left a little bit, about 20 degrees. And then you go about 1/3 to 1/4 of the previous distance. And again, you're at the object. So we have essentially three different ways. We can come from below right, and we can come from above right, and we can come directly from the face and shoulder of Orion. So three different ways, and they all intersect and cross-reference. That's a good way to learn about the sky in the first place and to find the object in the second place.
Excellent. No, that's great. Okay, and we have a couple of images here of what that would look like through different binoculars. So let's here we have the 7x50s, sort of your typical ones. Nice little star cluster down in the middle here, and I think Stellarium doesn't quite show as many stars as you would see in that cluster. It stands out quite a bit more, I think, visually than this indicates. And then if you've got the bigger binoculars, you get a little bit of a larger view there. You can see apparently there are about 1,000 stars in this star cluster, but we can't obviously see all of those with binoculars. That's very cool.
What you can actually see, and of course, the bigger the aperture, the better. It almost looks like six, six dots, six stars, and they are arranged in three groups of two above each other.
Right. Yeah, yeah, yeah. Yeah, it looks very rectangular, which is not the kind of thing
So
you normally would see. Yeah.
exactly, it looks very rectangular, very regular when there is no regularity around it, and that's what makes it stand out, I think.
Awesome. Well, thank you very much, Ulrika. That is, I love hearing your binocular stories, and I love getting to see new objects. This is something I'm going to take my binoculars out. I managed to snag a pair of the Meade 20 by 80 binoculars. There was the big sell-off of all of the gear from that telescope company that went bankrupt, Orion. And I managed to get a pair of 20 by 80 binoculars. They're in the mail now, and I'm waiting for them. So this will be my first target, I think.
Another good place to look for binoculars I found is in a thrift store,
Oh, yeah.
especially if you're a little bit out in the country. Uh, it's always worth looking. So you can find real treasures there. I once found like an original Jena Zeiss there.
Wow. Zeiss Optics are, well, that's the company that made our planetarium projector. So
Def-
I know Zeiss
Definitely.
quite well.
And I got them for $8. You don't get that in the mail.
I'm sure those were like $1,000 binoculars. The Zeiss company was at a conference I was at once, and they had a little telescope, um, and looked about the size of a $300 or $400 one, but it was $15,000 because it was just so precise optically. And anyway, it was wonderful, but I don't know if it was that many thousands of dollars wonderful, but still, $8 is a pretty good price. Nice job.
I have I have a special attachment to Zeiss because they are made in Jena,
Mm.
in Germany. And if you go on the Autobahn exactly 101 kilometers west, you're at my hometown. So
Oh,
that's
nice.
where
Okay. Well, next
all
time I'm
right.
there, I'll pop by for tea.
That's for me. I hope everyone has a good evening and a good rest of the week. You take
Awesome.
care.
Thanks very much. So Ulrika will be back more regularly since we finally have solved our technical gremlins. I'm just going to look at the chat now just to make sure. Oh, good. Thank you, Nasli, that you can hear us both. And you can only hear one of each of us. We had an echo another time. I'm so glad that this is working. Okay, so we can now have guests on the show. So if you would like to do a little segment on the show, drop me a line. I'd love to have you on the show, chat about the kinds of things that you like about astronomy. And yeah, and of course, we'll have Ulrika back regularly to take a look at the things in binoculars. Now, she mentioned the Rosette Nebula, which is actually a cloud of gas that is around this star cluster. This star cluster actually formed out of a big bubble of gas, and the gas in the middle formed the stars. So it kind of looks like a big donut, but it's very, very faint. But if you're in a dark location and you're using a small telescope or a big pair of binoculars, you might see a little bit of haziness, kind of like not as bright as the Orion Nebula, but you know that sort of grayish green kind of haziness surrounding the stars that make it look like, okay, it's not just a star. Well, I did some imaging of that area earlier this winter, and so this is my image superimposed on the binocular view, and clearly you don't see that level of color with any kind of optical device. The camera is needed for that. But there's that little star cluster right in the middle, and surrounding it is this giant bubble of gas that is still going to form more and more stars. Now this thing is actually so big. I didn't believe this when I read it, so I had to pull an image in and scale it the same way. It's twice as big as the size of the full moon in our sky. That's how much gas there is. It's a huge gas bubble that is just very, very faint, and so we normally don't see it unless you use a long exposure. But if you've even just taken exposures of the stars just with a camera on a tripod or something like that, people will sometimes find a little red dot in that spot, or a little bit of red wispiness, and that'll show up because it's actually surprisingly big and surprisingly bright for the camera. I wish we could see this kind of view with our eye, but alas not. All right, let us move on to let me see what, let's see, no questions. Oh, lots of people saying thank you and excited to go on the search. That is very cool. Lots of good stuff. Oh, James, you're here too. I didn't know. James is one of our regular viewers and is the sort of binocular guru of the local astronomy club, and is a binocular aficionado as well. So it's great to see you here, James. And let me see. I think the next thing we're going to do is wait for it.
Cool space stuff.
All right. So there's been a bunch of cool space stuff. First of all, the coolest thing is actually something that's not going to happen. This asteroid that was discovered on Christmas Day was, there was I think the most was a 3.1% chance that it was going to crash into the Earth in the year 2032. It's a near-Earth asteroid, so it loops around and it crosses our orbit. And so if it crosses our orbit when we're crossing that same point, it would actually impact us. And this kind of discovery happens a lot. There are lots of things out there in space, and usually what happens is something is put on the watch list, and astronomers, there's a 1 or 2 or 3% chance it's going to hit us at some point in the future. And that just gets the astronomers to focus on it and take a lot of images to show exactly what its path is among the stars. And as we refine the path, as more telescopes observe it and more data comes in, they can sort of take that target area and they can shrink it down because it's becoming more and more precise. And eventually what happens is it shrinks down enough that the Earth is not inside the target anymore. And so we know we know to the 0.005% level that it's not going to hit us in 2032. It took a couple of months to figure that out, partly because this asteroid is quite small. And so as soon as it passed us and started moving away, it became very hard to see. You couldn't see it in many telescopes. It's also in an area of the sky that wasn't particularly easy for some of the big observatories to get to. So it took a little bit longer than usual. Usually we get that kind of information in about 2 or 3 weeks. And so by the time anybody ever finds out that there's an asteroid with a 3% chance to hit us, the chance has already gone down to effectively 0. This one really made the news, and they were putting out maps of here's where it could hit if it hits us, and stuff like that. A lot of people were kind of freaked out over it. There were a few people who were bring it on was the funniest response that I heard. I guess it's just been a rough few months for some people, but anyway, it's not going to hit us. And it's almost certainly not going to hit the moon either. About a 1% chance still that it hits the moon. Now that would not be a problem. The moon would not get knocked out of it or anything like that. There'd be a new crater on the moon. But what a view. Can you imagine seeing something hit the moon and explode, and it would be amazing. if that looks like it's going to happen, I will fly wherever in the world you need to be to see that, because that's probably a once in a lifetime opportunity. Okay, let's get on some other cool space stuff that is going to happen. Robots landing on the moon. The Intuitive Machines moon lander launched just, was it today or was it yesterday? I think it was today, actually. And this is the one that, this is a private company working with some NASA experiments, and they landed and the legs broke and they had all sorts of issues. Their first thing, they successfully landed, but not all this technology worked. This is number 2. And so presumably they learned all the lessons, and we're going to see a cool landing on the moon. And they've got, again, a nice big camera on it so that we'll be able to see potentially even live images of the landing, which has never been done before. That'd be really cool. We're looking forward to that. And we're looking forward to another private company's lander that launched a number of weeks ago. It was looped around the Earth for a while. Blue Ghost transferred its orbit over to lunar orbit, and it's orbiting the moon. And it's going to land on March the 2nd in the Sea of Crises, which is a spot on the moon that we can see very easily, even with the unaided eye. It just occurred to me that if it was to crash, I don't think we'd be able to see that, because that's not a very large explosion. So it's not the kind of thing that you should fly wherever you need to be. Hopefully it'll land and give us some great close-up pictures of the lunar surface, as well as some of the science that is being used to sort of prepare the way for humans returning to the moon, assuming that happens in the next year or so. There's been some interesting studies that came out just recently in Nature about satellite pollution. And, you know, we've always known, okay, a rocket, when it launches, it puts some pollution out into the atmosphere. And up until recently, that has not been a large amount compared to the other sources. And some of the rockets that use hydrogen and oxygen, for example, just create water vapor. So they're actually fairly environmentally friendly. Some of the private companies still use stuff that's polluting or whatever. But up until recently, the re-entry of satellites has never been a problem, because, I mean, you know, how many satellites actually come out of orbit in a given year? A few dozen, something like that, and it hasn't been a big deal. Well, now SpaceX's Starlink satellites, the first generation, are reaching the end of their lifetime, and they're literally re-entering every couple of days. Here's a listing from, this is the upcoming re-entries of various spacecraft over the next little while. This is put out by the Aerospace Corporation, and they track re-entries. Almost all of them are Starlinks, and there's 5 pages like this, and almost all of them are Starlinks. So instead of a few dozen, we're now going to be looking at hundreds of these things re-entering. And apparently, when a satellite's made out of aluminum, the aluminum vaporizes as it burns up in the atmosphere, and that combines with chlorine, and that can then fall back apart and release chlorine in its sort of native form out into the ozone layer, essentially, and damage the ozone layer. So even though we solved the ozone problem back in the 80s and 90s, we got rid of all the CFCs in hairsprays and all that kind of stuff, there's now another threat to basically the layer that makes Earth livable, and it's from these satellites. Again, nobody ever considered what it would be like if suddenly there were 60,000 of these things, and 1,000 of them re-entered every year instead of a few dozen like we have now. Often humans, when we do things, we don't really think about scaling them up, and then someone scales them up, and then we learn after the fact. So this is a little bit disturbing. This was a farm in Saskatchewan. A rocket from SpaceX fell on their farm, and I remember hearing the story. It was last summer. I remember hearing, oh yeah, they found some pieces, but I never saw the pictures. Look at the size of this stuff. Like, this is like half a rocket, it feels like. There's got to be a better way to do things. And so hopefully there'll be a little bit more thought put into how to deal with these spacecraft rather than letting them just fall out of the sky and wherever they land, they land. Okay, on to something a little more positive. James Webb Space Telescope has, as you probably know, a Canadian instrument on board, and some Canadian astronomers are using JWST to study an ultra-hot Neptune. And so planets like Neptune, we call them ice giants. In our solar system, they're way out at the edge of the solar system. They're kind of icy in the middle, and then they've got an envelope of gas around them. Well, here's one that is in 10 times closer to its sun than Mercury is to ours. How can an ice giant survive right next to a star? We have no idea. But they've figured out using the James Webb Space Telescope that this planet is tidally locked. So one side always faces the sun, kind of like the way the moon always has one side facing the earth. We always see that same side. And along the edge, sort of in the sunset zone, there's a whole bunch of clouds that are reflecting radiation differently. So they're sort of mapping out the atmosphere of this really rare, I think this is the only ultra hot Neptune planet known to exist right now. So kind of studying the odd planet to figure out, a little bit more about how planets work. This shouldn't be possible using the old formation of the solar system models that we use for our solar system. Every time we look at other planets, we find out what a freak our solar system is in terms of, having everything just nicely ordered and having, all the rocky planets in close, and then one planet just the right distance from the sun that life can exist, and then all the gas giants out there, and then all the ice planets at the outside. That's not the way any other solar system is. So that's kind of an interesting thing to think about. Do we live here because our solar system is a freak? Is our solar system a freak and we just happen to live here? What does that imply for the likelihood of finding life elsewhere in the universe? Lots of big questions. Anyway, it's cool that there are Canadians working away on trying to answer some of those big questions with the best telescope in the world. Okay, let me see here. We have a couple more. I'm just making sure I didn't miss any chat stuff. Okay, good. There we go. There's my background. Much better. Okay, so we do these shows at the end of the month so we can preview the next part of the month. We've talked about the planets already. We're getting into March where it's kind of your last chance to see Orion and the winter constellations in a dark sky. They'll still be up in April and May, but they'll be really down low into the sunset. And so if you want to get, a good view of the Orion Nebula or any of the Pleiades star cluster or any of those kinds of things, this is really your month to do it. But there's also a big event coming up, which is greatly anticipated. It is the lunar eclipse coming up on, well, again, the almanac says March 14th. That's universal time. That actually means it starts on the evening of the 13th. Thursday, March 13th to Friday, March 14th. That's when the lunar eclipse begins. And eclipses, people think of eclipses and they think of the solar eclipse that we had back in April of last year, or total solar eclipses that we had across the United States and Canada that day. This is not that. A lunar eclipse is not, you must be in a certain spot. The entire side of the planet gets to see the same view. And it's not something that lasts, 2 minutes and 37 seconds, and then after that it's over. This is something that lasts literally 6 hours. So it's an all-nighter. And that can be a challenge. But, we've done it before. I've been out in minus 35 for a couple of these to live stream. We're going to do it again. We're going to be live streaming in coordination with the Royal Astronomical Society of Canada Winnipeg Centre. Our friend James Fass is going to be there, and Wing Kwong and a few other folks, and we're going to take a stab at providing color commentary for the eclipse for the entire event. So here's what's happening. The moon is moving into the shadow of the Earth. And the shadow of the Earth, this is not to scale, the distance is way off, but gives you the idea. The Earth has a shadow where if you were in here, you couldn't see any sun at all. And then the Earth has part of a shadow that if you stood here, you could see part of the sun, but the Earth would block out part of it. So there's these two layers of the Earth's shadow, the penumbra, the outer fainter part, and then the umbra, the darker part. And so when the moon moves in there, at first it darkens a little bit, and then you get into the darker part, and then you would think it should completely disappear because the moon only is visible because there's light shining on it from the sun. So if it's totally in the Earth's shadow, shouldn't it disappear completely? Well, it would if the Earth had no air. But luckily, the Earth has an atmosphere. And I'll come back to that picture because I set up this one. This is the view you would have from the moon during a lunar eclipse. The sun is totally blocked out, but some sunlight is sneaking along the edge of the Earth, going through the atmosphere. And just like when the sun is setting and it's low in the atmosphere and it turns red, the only light that gets to the moon during a total lunar eclipse is the combined red light from all of the sunrises and all of the sunsets all around the world at that moment. So the moon is bathed in that red sunset glow, and that's why the moon turns red. Now, if the atmosphere is not very clear, that can block out more light. Sometimes it's a very, very dark red color, and it's hard to see. There was one year where a volcano had just erupted in the Philippines, and the air was so full of ash, fine particles, that the moon actually turned black during the eclipse. It didn't turn red, it just turned black, and you literally couldn't see it unless you knew exactly where to look. We probably won't have that happen. We'll probably have a nice typical red, coppery, orange colored eclipse. And it is beautiful to see because as the moon moves through the shadows, the amount of light it gets is ever changing. So you're getting all sorts of different, like minute by minute, you're getting different views of the moon. Having said that, it is slow, so you could still go out every 15 minutes and not miss too much. Or you could just watch the stream, and we'll do a time lapse for the morning. So you could just get up in the morning and watch it that way if you want. But it's pretty magical to see in person. And the great thing is you don't need any special gear. You don't need a telescope. The red color is obvious to the eye. If you do have binoculars, those are great for observing an eclipse. So that's the kind of gear that you need. Now going back to this picture, I said half of the Earth gets to see the eclipse. The whole side of the Earth that's facing the moon gets to see it. But the Earth is turning, and over 6 hours it turns about a quarter way. So there's actually only this part of the world gets to see the whole eclipse from beginning to end. These various points are like, well, it sets during the partial phase, it rises during the partial phase, and you can figure all that stuff out from this kind of drawing. But if you're in this area, you just don't care because you can see the whole thing. And there we are, right there. That little dot of light is Winnipeg, right here in Treaty 1 territory. So we're perfectly placed for this one. All we need is a clear sky. So here are the times. Basically, it starts just before 11 o'clock on Thursday night, the 13th. The beginning of the eclipse is not something that you will necessarily be able to see right away, though. The edge of the Earth's shadow is fuzzy, and it doesn't have a hard edge, so it just sort of fades in, and one side of the moon starts looking a little bit dusky. I usually don't even notice the beginning of the eclipse until about 15, 20 minutes in. Once the moon goes into the darker part of the eclipse, that happens about 12:09 Central Time, Central Daylight Time. We're on daylight time at this point. That's when you'll start to see a curved line of shadow slowly creep across the moon. The total eclipse starts at 1:25. Greatest eclipse, that's just when the moon is in the Earth's shadow the deepest, and so that's theoretically the darkest part of the eclipse at 1:58. And then the total eclipse ends at 2:32. So that's over an hour of totality to see the glorious red colors. And then the whole thing just sort of undoes itself as the moon moves out the other side of the shadow. and it goes till 5 in the morning. I can't guarantee that we will make it till 5 in the morning on the live stream, I have to say. We will definitely make it through the end of totality, and then as much as we can. But even having the day off work the next day is not necessarily enough for me to be able to do an all-nighter anymore. Well, what's that going to look like? Here's a video I put together with Stellarium, making a picture every 2 minutes. There you can see the penumbral eclipse starting, and it's very subtle, but the moon does dim quite a bit. And then there's the umbra, the darker shadow of the Earth. And as it gets to about, maybe halfway, the shadow looks dark because the bright moon here is sort of dazzling us, and the glare from that just makes the shadow look dark. But as the shadow covers more and more of the moon, as that bright part gets smaller and smaller, you wind up getting some of the glorious colors start to come out in the shadow. And that's when the red color starts to become visible. And that's also, oops, I apparently reset the thing. That's also when the stars start to become visible in the background. And there you have, I don't want you to reset, I want you to pause. Sorry. Video in PowerPoint. Never something that is reliable. So there you have your total eclipse. And I'm going to try and stop the thing, but it's not going to let me. Nope, it's not going to let me pause it. That's very disappointing. Anyway, one of the things that's kind of cool is during the eclipse, the moon is still moving through the sky, and the eclipsed moon will eclipse some stars as they go in behind it. So as we're watching this, we'll get to see these stars get eclipsed by an eclipsed moon. That's kind of cool. And then you see the shadow starts to brighten up, and then you get these great colors, and then the whole thing undoes itself. This video is available on the Manitoba Museum's webpage, and if it's not, then it will be shortly, because my blog goes up I guess today, actually. It should be up. And that'll be available. This is the view from southern Manitoba. As the moon rises and sets, it sort of seems to rotate a little bit. People in different parts of the world will get slightly different view in terms of the orientation, but the times and the shadow and the view will be basically the same. So if you convert it to your time zone from the central time that we had here, you'll get the same thing. And you pretty much can't go on the internet without seeing somebody posting lunar eclipse times right now. So it's pretty easy to find that information. So you can join us for the live stream. We'll be streaming to a number of different locations. For sure, one of them will be wherever you're watching Dome at Home, and it'll probably also go out through the RASC's sites and things like that. We've had times where we've had 1,000 or more viewers at a given time because other places are cloudy and we happen to be clear, so people can watch with us. If we're cloudy, we can watch online from another place. But this is a big event, one of the better events of the year, so definitely worth taking a look at. And I highly recommend that you make plans to observe the total lunar eclipse. Remember, Thursday night into Friday morning, not Friday night, which would be so much more convenient, at least for me, but that's the way it is. You know, you take what Mother Nature gives, and there's really no sense in complaining. That brings us to the end of our show, and I hope that you enjoyed the various things that we did in the show today. We'll be back next month, the last Thursday of the month, with a number of different things. We're hoping to have another guest to be announced, and we're also hoping to have some of your pictures of the lunar eclipse. So anything you do, whether you take pictures through your telescope or just with your phone, or whether you do a drawing. I actually saw someone that did a watercolor painting based on a picture that they took. I'd love to see however you experience the lunar eclipse. And that will be a feature of next time around. I'd like to thank everybody that contributed to the show this time around. And where is there we go. So Fallon and Andy and Ruby, thanks for your pictures, and then the various space agencies and so on for supporting the use of their images in programs like ours. you can always join us online through Facebook and YouTube. And the museum is actually just setting up a Blue Sky account, and we are no longer on Twitter or X, so you can't find us there anymore. But Facebook and YouTube. YouTube's probably the best place to watch archived shows because it doesn't require membership. If you want to contact me, the best way is definitely by email, space@manitobamuseum.ca. Thanks, everybody. I want to get back to the chat here one more time just to make sure that we haven't, let's see, if theory, oh yeah, oh, hey Bob, nice to see you. In theory, if you're on the moon, this would be a solar eclipse. Yeah, absolutely. Although the Earth appears bigger in the sky, and so you wouldn't quite get the same kind of solar eclipse that we get, where the moon just blocks out the bright part of the sun and then you get the flames around it. The Earth, it would be like twice as big, and it would sort of cover up that whole thing. So it wouldn't be quite as cool. And it's a lot harder to drive to the moon than it is to drive to, Toronto or Nevada or something like that. All right. Thanks, everybody. Have a great night. I hope we get some clear skies, and we'll see you all soon. Have a good evening, and we'll see you next time on Dome at Home.